Alright, so welcome back. I'm going to try to do at least an hour, and I'm going to get through this. Here, I might do one more video to get through that. And that would just mean getting through one topic today. So I wanted to get through two topics. So, that would be wonderful if I could get through two topics, because then I would finish up all of L2 VPNs, and I just have the final two topics to worry about for this last month. That would be wonderful if I could do that. So yeah, let's aim for doing that. Next is going to be connecting layer 3 VPNs to layer 2 circuits. Applications for connecting a layer 2 circuit with a layer 3 VPN. Mpls-based layer 2 services are growing in demand among enterprise and service providers. This creates new challenges related to interoperability between layer 2 and layer 3 services for service providers who want to provide end-to-end value-added services. There are various reasons to stitch different layer 2 services to one another and to add layer 3 services. For instance, to expand the service offerings and to expand geographically. The Junos OS has various features to address the needs of the service provider. You can enable pseudo-wire services and configure a pseudo-wire service interface as an access point for interconnecting layer 2 circuits to layer 3 VPNs. For more information, see pseudo-wire subscriber logical interfaces overview. Interconnecting a layer 2 circuit with a layer 3 VPN provides the following benefits. Interconnecting a layer 2 circuit with a layer 3 VPN enables the sharing of a service provider's core network infrastructure between IP and layer 2 circuit services, reducing the cost of providing those services. A layer 2 Mpls circuit allows service providers to create a layer 2 circuit service over an existing IP and Mpls backbone. Service providers do not have to invest in separate layer 2 equipment to provide layer 2 circuit service. A service provider can configure a provider edge router to run any layer 3 protocol in addition to the layer 2 protocols. Customers who prefer to maintain control over most of the administration of their own networks want layer 2 circuit connections with their service provider instead of a layer 3 VPN connection. Example, interconnecting a layer 2 circuit with a layer 3 VPN. I had some floss here. I do. Okay, yeah, I'm gonna need it. Alright, that feels much better. Okay. This example provides a step-by-step procedure and commands for configuring and verifying a layer 2 circuit to layer 3 VPN interconnection. It contains the following sections. Okay, so it looks very similar to the topology they had before. So the logical topology of a layer 2 circuit to a layer 3 VPN connection is shown in figure 2. So we've got the L3 Vpn connection between PE3 and PE5. It looks like these are part of a L3 VPN. Then we have an L2 circuit terminating into the L3 VPN. So it looks like this PE is not a part of the L3 VPN. So I think, wouldn't you need a mesh group? You need that for VPLS. For here, I'm not sure. Okay, so now this is a L3 VPN, so we're going to need a full mesh of IBGP connections. So they're going to use a route reflector. Let's just go through, and I'm kind of tempted to blank out everything, but oops, so it looks like they've got family MPLS enabled on things. I don't see... so they're also going to have family RSVP, and then they'll have BGP to the route reflector, and it's going to have to be for everything, and they'll need a full mesh of it looks like they need label switch paths to... Oh, you know what? Maybe that's what was... Huh. It's just, I'm surprised that they have a label switch path to the route reflector. But I had set up a layer 3 VPN successfully, so... And I didn't have that, so I'm not sure what's going on. Okay, but let's take it more step by step. Jump up to the top. And we'll go down to configuration. Okay, so let's start with configuring PE, router, customer-facing, and loopback interfaces. To begin building the interconnection, configure the interfaces on the PE routers. If your network contains provider PE routers, configure the interfaces on the PE routers also. This example shows the configuration for router PE2, router PE3, and router PE5. On router PE2, configure the JE102 interface encapsulation. To configure the interface encapsulation, include the encapsulation command and specify the Ethernet CCC option. VLAN CCC encapsulation is also supported. Configure the JE102.0 logical interface family for circuit cross-connect functionality. To configure the logical interface family, include the family statement and specify the CCC option. The encapsulation should be configured the same way for all routers in the layer 2 circuit domain. Okay, so yep, it's the same encapsulation we used in the last one. On router PE2, configure the LO0.0 interface, include the family statement, and specify the INETs option. Include the address statement and specify 192.0.2.2/24 as the loopback IP address. Okay, so this week I've got more of a understanding of, we already did all that, so I'll just skip down to the next step, which is configuring the core facing interfaces. Okay, and this we've already got set up as well. So the next step is going to be protocols, and we're going to use This procedure describes how to configure the protocols used in this example. If your network contains P routers, include the interfaces on the P routers also. On router PE3, enable OSPF as the IGP. Enable Mpls, LDP, and BGP protocols on protocols. LDP is used as the signaling protocol for the layer 2 VPN circuit. Oh, I see. Okay, so yeah, our VPN is going to use RSVP, but we're going to have LDP enabled for our L2 circuit because that relies. So we've got extra configuration for the L2 circuit. You don't need to have both RSVP and LDP configured in order to just run a L3 VPN. You need either one or the other. I prefer RSVP because I have more practice with it. And because it gives you more control. Okay, so let's jump over to the appropriate router and configure our protocols. Okay, so we can get rid of this hash key statement. Oh man. I got a pretty bad stomach ache. Oh man, I really get sneaky. I might need to pause it and come back for a bit. Come back in a bit. See, I don't know which... Okay, yeah, I don't know what's there. It doesn't say anything about tracking mode, but yeah, I'm gonna flip it back to the mode that I've been using so far. I'm just gonna blank these out and then we go from there. It'll give me practice, and then while these are and then while these are coming back up again, I can try to fix my stomach ache. Yeah. Okay, so this one was already set to... Oh, no, it doesn't give you the warning until after it commits. I was expecting the warning after I entered the command for some reason. I'm kind of off my game right now. My stomach is like really hurting. Okay, so we won't need to reboot this one because we're not going to change the network services mode. Okay, so we'll go through step by step everything, configure all the interfaces, all that good stuff, and we'll do that when I come back, and I'll be back once these are back up here. I'm not sure what they're gonna say about the PE routers. Okay, we can just get rid of these for now. Yeah, there we go. So yeah, when those are back up, we'll set up all the rudders, all the interfaces, then all the core interfaces, then all the protocols. We'll do it exactly as it comes here. Perfect. Yeah, this will make everything nice and clear. Okay, so I'll be back shortly. Okay, I'm back. I've got the recording unpaused. It looks like I had 18 minutes up there already. I forgot what I was doing. Oh, okay. Actually, now I remember. I was blanking out all the routers and rebooting them because I just want to follow that documentation hand in hand because I'm still kind of unfamiliar with what they're doing. So the CE routers, right now I don't have blanked out. I won't need to change the Triton mode on those though, so they won't require a reboot, so the time spent on those is pretty much negligible. But let's go and configure the loopback addresses and the physical interfaces on all of the PEs for the CE facing links. This is going to be GE000. So this part I didn't need to wipe out this config, but there's no harm in. I mean, there's time lost, but it's not a big deal. All right, so let's remind myself on what is required. Oh, so is this a? Yeah. So these are the CE facing interfaces, and then you also need one for the core facing interface, but that's going to get a. Wait a minute, I'm confused. Because I thought this was a layer 3 VPN. Yeah. Oh, okay. So I think what we have here is we're gonna have a layer 3 VPN, yes, but we're gonna have one PE router that's not a part of that layer 3 VPN. And it's going to connect into that layer 3 VPN. So I've got to make a choice for which routers belong to the layer 3 VPN and which router does not. And the routers that belong to the layer 3 VPN are going to have different interface configuration for the interfaces facing the CEs. Yeah, so, oh, these are core facing interfaces. Okay, so, yeah, so customer facing and loopback interfaces. We see we've got customer facing interfaces on PE2 that have that. But now on PE3 we've got a customer facing interface that has layer 3 on it. So let's do this. Let's think about our onion addressing, where we've got 1, 2, and 3 going this way, and instead of 3, we're gonna make this the PE device that connects to the CE on layer 2, and then uses an L2 circuit to tie into the layer 3 VPN, which is actually going to be shrunk down now, and the layer 3 VPN is just going to include these routers here, and this is going to be outside of the layer 3 VPN, but it's going to tie into it using a L2 circuit. Okay, so that's going to change considerably the kind of configuration we're going to need. On here, we're going to need family INET addresses facing the CE, but here we're going to have that encapsulation Ethernet CCC. So I'm just going to blank out the CEs right now too, because that's kind of bothering me. I don't want to make it a little bit harder on myself by going in and thinking that I've got that set up right, and then realizing later that, oh wait, I haven't finished that yet. I'd rather just have it blank than have to then get a false idea that I had finished it. Oh, you know what? Maybe it's I don't know why I'm having trouble. Yeah, I'm having a lot of trouble entering the password. Alright, let's try it on this one. Maybe it's just me. Okay, so things were fine on this one. Oh, you know what? I think I might have entered the wrong password. Because I entered in the hash. Yeah, so I think I might have entered the hash incorrectly, so now I don't have a password set that I know what the password is. Yeah, I think I set the incorrect password. Try it again. Yep, so the password's not set to something that I know what it is. I'm gonna have to destroy the router and then put a new one in its place. That's the only way. So unfortunately I'll need to wait for it to boot, but I've got plenty to do in the meantime, so it's not a big deal to just sit and wait for it. Boom, go away, bye bye. Well, I gotta make sure I don't have more than just that selected though. Okay, so I've only got those 2 selected, so bye bye. Okay, and then I'll have a... Oh, I could have just destroyed the control plane instead of the forwarding plane and the control plane. That would have actually worked to my advantage. But I didn't do that because I was not thinking. Okay, so let's close GNS and reopen it so it looks a lot cleaner. It's just the client is having trouble processing those icons. So There we go. Now that looks like what I was expecting. So we'll need to do a new one. Perfect. Oh man, I'm feeling kind of tired. My stomach does not hurt anymore. I feel kind of weird. Like I feel like sometimes there's like a really weird feeling where like you ate too much. You've ate too much calories. You know you're gaining weight. You know you're on the wrong track. But yet you're just absolutely hungry. It's like, wait, how can I be hungry if I've been gaining, so much weight and, I've eaten so much more today than I know is healthy for me? How can I possibly be hungry? And I'm getting that feeling where it's like, I'm hungry, but the tank is full. I can't exactly eat because I don't even have room to eat. So why? It just makes no sense that I'm hungry, but yet I'm hungry. That's a really weird feeling that I get far too often. Okay, so yeah, let's keep on topic. My mind is obviously wandering a lot. I'm really not doing a good job today keeping my mind focused, which makes sense because as I've been complaining about, my weight is completely out of control. I had my highest weigh-in ever since I moved in like probably more than 10 years. So obviously that's going to affect my mind. I might want to try to come up with an exercise and diet regimen so on test day I don't have to worry about my mind being this far off the rails. That's a good idea, actually. I've been thinking about getting, because basically I just need to find a way to measure the amount of calories I'm eating during the day and really stick to that. Okay, so let's see here. Right, okay, so we're good to go now. Waiting for this to boot up. That's going to take a while, but it doesn't really matter. We just need to configure the physical interfaces and loopbacks of all of these rudders. The physical interfaces for the PEs belonging to the L3 VPN are going to get family INET IPv4 addresses, but the physical interfaces belonging to the PE router that is outside of the L3 VPN just gets that encapsulation CCC interface without an IP address. Okay, so let's get started. Edit interface 000.0 on R4, so set family INET address, and we'll use the onion addressing. It's going to be 10 dots, the inner layer dot, and then this is the first one, dot 1/30. Oh wait, sorry, no, this isn't the inner layer. This is still the first layer. It's just the other side of the first layer. Yeah, and we'll go with dot 2 because it's connecting. Yeah, so this is the first layer of links here. So it's going to be dot 0, dot 1, dot 2, and then here we won't need one, so we'll just leave it blank. Or sorry, well, yeah, well, so we won't leave it blank. We'll go with encapsulation CCC. Perfect. Okay, so that looks good to me. I might as well just take care of the other side as well. Let's do a description on this as well, just to make things easier. And it's going to be customer facing. Okay, and we'll go to top edit. Core facing. Yeah, so here we're gonna have .1, which is talking about this layer here, and then .1, .2, and we will need one here, so that's gonna get .3. So this is 10.1.1.1/30, and then we need a loopback. And it's gonna be 192.168, and then we're doing the same thing. The loopbacks on here are 0, then the inner layer are gonna be 1. And it's going to be /33. Oops, there's a show pipe compare. We've got all that in there, so we'll do a show pipe display set relative. And I'll just grab this to make it easier for the next ones. Okay, so the next one is going to have .2.2. It's going to have .2.1, and it's going to have .1.2. Perfect. Okay, time for the last one. The last one's going to be quite a bit different because this customer-facing interface is no longer going to have an IP. Let's take a look at the documentation to see how it's going to be different. So it's going to be encapsulated with Ethernet CCC at the physical hierarchy, and then under the logical unit, unit 0, it's going to get family CCC. Okay, and then we've got to, of course, change the addresses here. This is going to be okay. Looks good to me. But it's going to be on Rudder 6. Yeah, thinking of it like this, as if it were a circle, really makes sense to me. And then of course you can collapse it down to any topology, span it out. I think when you learn L3 VPNs, I wouldn't recommend anyone watching this right now to just learn it with a set, with anything like this. You really want to think of it like a wheel, like a circle. If you just learn it like a flat line, as it's shown in many of the examples, you really won't have a sense that what it means that there's a provider edge, that there's a provider, that there's a route reflector, that there's a customer edge. You won't get a sense of layers and the fact that it's kind of like an onion with layers. And that, to me, I think is really allowing this to kind of click in. I really get a sense that I'm making sense of this. Oops, I would love to copy this, please. Thank you. And paste it. Excellent. All right, so we're good to go with that. I think they wanted us to do the P routers as well. Oh, so that's going to be for the core interfaces. So I skipped ahead and I did the core interfaces. It looks like I did them wrong. I forgot family Mpls. So we'll go back and take care of that. Okay, and we'll need it on all of them. Oh, not family INET VPLS, family VPLS, perfect. We just need that on the core-facing interface. We don't need it on customer-facing interfaces. Alright, so that looks good to me. Moving on. Okay, so the next step is going to be configuring the protocols on the CE. Yeah, so in this step they do say to do the P routers as well. Let's configure all of the interface IP addresses in the P routers, and then in this one we'll save the protocols configuration for this next step here. So we've got 2 P routers, so let's take care of them. Alright, and we'll use the same onion addressing. So starting with GB002. So it's going to be 10.1.1.2. Yep, and then and 1.2.2. Okay, and this one is going to be a 10.2. And we'll do that 1.1. Alright, looks good to me. Time for the next one. And I'm wondering, maybe in the last topology where, oh no, because it would have just affected this link. I was wondering maybe it wasn't working because I mis-IP'd this link, but I'm pretty sure I had the IP addressing correct. I mean, that's something I can always go back in. I can actually verify that really quickly because I can see if this is being learned through OSPF. If it's not, then I know there's a problem. And not only that, all of the BGP neighborships came up, so the IP addressing's got to be right if it's able to bring that to form a TCP connection. Okay, so it's time for router 9. Oh, I think I've already got... Oh, sorry. It's going to be... I already have that configured? No, I don't have that configured already. It's going to be 10.1.3.2. Okay, let's see if I can ping 10.1.3.1. Otherwise, I've got a problem here. We'll see if I can ping both sides, but we'll start with 10.3.1. Okay, and we'll start with, and then we'll end with 2.1.1. Perfect. So everything looks good to me. What's the next step gonna be? Oh yeah, the protocols. Okay, so we've got to enable basically the same protocols, but we do need to build a full mesh of MPLS Lsps to all of the routers in the topology. So this procedure describes how to configure the protocols used in this example. If your network contains P routers, configure the interfaces on the P routers also. On router PE3, enable OSPF as the IGP, enable protocols MPLS, LDP, and BGP protocols on all interfaces, except the management interface, but we'll skip that. We'll just enable it on all. LDP is used as the signaling protocol for the layer 2 circuit to router PE2. The following configuration snippet shows the protocol configuration for router PE3. Okay, so we just need label switch paths to our PEs. It looks like they've got more PEs than I expected. We're also going to need one to the route reflector, which I'm surprised by. But we'll have router 8 serve as the route reflector, as we had in our previous topologies. Yeah, so they've got a route reflector here off of a P router, not connecting into any other. So I guess a more proper topology to have a route reflector be a part of, you would have a link straight from R6 to R8. Then you have R9 branching off from R8, not being a part of any of that, and then R9 would serve as the route reflector. But we're going to have R8 serve as a dual role router. It's going to be a P router and it's going to be a route reflector. So maybe that's my problem right there. Maybe that's why things weren't working for me. But we can always try. We can try fixing that if it doesn't work. But I'm pretty sure I remember I did have a L3 VPN up and running perfectly before, so hopefully it's not going to be a problem. Now, one thing we got to remember too is that we've got basically a dead site in our L3 VPN because we're just going to connect to this using an L2 circuit. So our L3 VPN label switch paths are just going to include these two routers here, router 5 and router 4. Okay, so let's start with router 4. Now we're going to need LDP for that L2 wire, L2 circuit. So I think it's going to be between this router and the other one. I'm a little bit confused about this, but okay. So I've got LDP configured. I've got RSVP, MPLS. I'm going to need my label switch path for that. So let's do that. There we go, and it's going to be 2 RR, and then it's going to be R8 is the RR. Okay, and we'll need, oops, I forgot to set up a loopback on these two, so let's do that now. So loopback addressing is going to be 192.168 dot. I believe it was, let's see what the loopback is for R4. Okay, it's .1. So yeah, it starts with .0, .1. So these P routers are going to have a loopback of .2. Yeah, so this is going to be .2, .1, and then we'll make that .2.2. Yeah, that's something I didn't have before, so we'll have that now. And let's add that 2 over here. Okay, so we're good to go. We are good to go. Let me think here. Let me think. Okay, so now we can set up our legal switch path. Now that we've got loopbacks to actually form it too. And I probably didn't need one on R9, but I just have one there anyways. Okay, so I need one more legal switch path to the other PE. Okay, but that's all I'm going to need. Alright, and then the final protocol is going to be the BGP group to the route reflector for the internet VPN traffic. We're also going to need to enable L2 VPN signaling for that L2 circuit. So we'll also need a autonomous system. We'll just go with autonomous system 10. Local address is just be 192.168.1.1. Okay, so, oops, and I forgot about OSPF. Okay, so we're good to go. Yeah, we're good to go. Okay. Yeah. And let's gather this up so that it's easier to apply to the other router. We'll just need to apply it to one more router. I believe, actually I'm not sure about that. This one stays the same, this one changes to router 4, which is at that one. Okay. Local address, so there's the autonomous system, let's make it 10. It's going to be dot 2. Yep. Looks good to me. Oh, I need a common system as well. Okay. Oh, my camera stopped, so I will restart that. Which is really scaring me because it's going to have to be started. It's going to have to be on the whole time during the test. Any screw-ups could mean an instant fail. Okay, there we go, it's back. So I might just need to find a better solution or something, or I can use my, I might just want to use like my computer camera, because that's, I think, less likely to fail than a external camera. That's a good idea, that's a smart idea, I might do that. Because they just need to like basically see my face, I think. I don't even know what they need to see. It's going to be a nightmare. Okay, so yeah, we got the protocols applied to both of those. So next step is going to be I guess I wanted to say next up is going to be the route reflector. I thought they gave the route reflector configuration. Oh yeah, they gave it down here, but they're going to give that after we configure the L2 circuit and the L3 Vpn. Okay, so we're going to add the protocols next to the PE, to the other PE and the P routers. So let's see here. So on router 2, okay, so on router 3, enable, okay, so they want it done on router 3, router 2, and router 5. Okay, and then router 2 is going to have the virtual circuit. Router 3 and router 2 are going to have the virtual circuit to each other. So yeah, they want all of this configuration on router 2 as well. Okay, so I've got to add this to router 2 as well. Yeah. Okay. Yeah, so we've got to do all of this on router 2. Okay, so I need another one of these. Okay. This could mean. Okay, yep, so this goes on router 6. I might need some water quick, but oops, I forgot that I was on the system. There we go. Okay, and then yeah. Oh, oops, I forgot. We gotta add the missing little switch path to router 6. There we go. Okay, looks good to me. Of course, we're going to need to... Now, did I already configure the protocols on here? I believe I did. I don't remember though. Let's check. Nope, I didn't include any protocols configuration there. Let's wait a little bit on that. Okay, and instead let's do this configuration. Okay, so is Rudder PE2 the one that's meant to be part of the VPN? So Rudder PE3 gets VPN, and Rudder PE5 gets VPN, but Rudder 2 does not. So in our lab, Rudder 2 is going to be the equivalent of 6, so this configuration here is going to go on Rudder 6. Okay, and then it can go to any one of our choice. It doesn't matter. I'm going to go with R4, which is at 1.1. Oops, we got to do edits, interface. And it's going to be the customer-facing interface. So, run showing subscriptions. Okay. Perfect. Okay, so now on Rudder 4, we're going to need another virtual circuit ID. Yep, and we're going to need to specify a logical tunnel. Okay, we don't have any logical tunnel interfaces. Let's see if we can enable them. Okay, so hopefully we get the logical tunnel interfaces now. Aha, we got it. Oh my god, so happy. So happy to have that. Okay, so let's, oh, it looks like it's down, but hopefully it goes up after we add it. And they've got 1110. Looks like we got 000. Excellent. So hopefully this works. Excellent. It worked. So now we can add the L3 VPN configuration to R4 and R5. R6 does not get it. It's going to be outside the L3 VPN, and it's going to tie into it with a L2 circuit. Okay, so let's add that L3 VPN configuration. It's going to be the customer-facing interface. Okay, so the route distinguisher is going to be the AS. Let's go with the IP address. And we'll do 10. Yeah, we'll go with our AS, which we chose as 10, and then just the number 1. So this is VRF label table. Advertise a single VPN label for all routes in the VRF. This might have been what I forgot before. I'm not sure why they want this command there. Let's look up that command quick, just to refresh myself. Map the inner label of a packet to a specific VPN routing and forwarding VRF instance. This allows the examination of the encapsulated IP header. The first lookup is done on the VPN label to determine which VRF instance to refer to, and the second lookup is done on the IP header to determine how to forward packets to correct end hosts. When you include the VRF table label statement in the configuration of a VRF routing instance, a label switched interface LSI logical interface label is created and mapped to the VRF routing table. Any routes in the VRF routing table are advertised with the LSI logical interface label allocated for the VRF routing table. When packets destined for the VRF routing instance arrive on a core-facing interface, they are treated as if the enclosed IP packet arrived on the LSI interface and are then forwarded and filtered based on the correct table. All routes in a VRF routing instance configured with this option are advertised with one label allocated per VRF. Okay, so that's a lot to take in. It's a bit over my head. Now is this the, yeah, okay, so this is the second video of the day for this. I'm just gonna add this to the notes. Yeah, right now I'm taking the second video and I hope to do one more for layer 2 VPNs, so I hope to be pretty quick with this. I might just get done with one topic today. I kind of hate to do that because the time is really ticking, but it's going to be important to be satisfied by my study, because if I'm not satisfied and I go into the test thinking I don't know what I'm doing, that's going to be a big problem. And it's probably better to be really confident in all the subjects I studied and miss a few subjects than it is to study all the subjects and be kind of lost and confused. Okay, so this looks like they're having a eBGP connection to the CE. So the CE to Rudder 4 is going to be 10.0.1.1. Okay, and then we didn't specify a pure AS for it. Let's specify an AS of 5 though for it. Okay, so that looks good to me. God damn it. Okay, so it looks like they want configuration for this L2, this special interface here. There's no instructions for how to configure this. Oh, there is instructions. Okay, so yeah, there's instructions down here for how to configure it. And it's going to be on P3. Yeah, so this is right. Okay, so let's configure that interface so we can commit this. Okay, so I'm not sure what the deal is with this. Let's just go with a new enter space. So we'll get 172.16.0.1 /24. Still doesn't work. Huh. Okay, I'm getting confused now. I don't understand why this isn't getting. Well, I mean, I have the. So it says that LT is not configured under the master routing instance, but it looks like it is. So I don't know what they're talking about, because it's configured. So what the heck? Why do they think it is not configured? It's right here. It's configured. It's definitely configured. Did they want that one? Oh, maybe they wanted .1. Oh, right, yeah, they wanted .1 because that 0 is for the L2 circuit configuration. So that's the problem. Let's fix that. Oh, okay, perfect. So now we got past that error. So the next one is going to be the export policy. It was not defined, but it looks like it's pretty self-evident what it's meant to be, even though it wasn't given. So direct. Oh, I have set so that that's what it's actually strange. Alright, looks good to me. Alright, perfect. Time for the next one. It's going to be Rudder 5. Oh, it's going to be the customer-facing interface. Oh, okay, so they're having different pure ASs. We went with pure AS 5 for the next one, so this one's with pure AS 6. And this should be all we need. Hopefully the route targets match. I forgot what I used in the other one. I'm going to double check that quick. Yep. Okay, so the next step is going to be configuring the route reflector, which for me is Rudder 8. Okay, and we're going to need label switch paths to all of our PEs. Okay, so here's where L3 VPNs are different from VPLS. With the L3 VPN, you need a neighborship to all routers in your topology. With VPLS running at layer 2, you only need a neighborship to the PEs. Okay, and we'll do passive so that the neighborships come up a little bit faster. Okay. Alright, so I think that's all I need. Yep, that's going to be it. Oh, of course we need a autonomous system. Alright, that looks good to me. Okay, and I think I'm missing BGP configuration on the PE. I think that's going to be required. I think I have no idea. I'm so confused. So let's see. We have 1, 2, 3, 4, 5 connections. Let's see how many routers we have in the topology. In the topology, we have 1, 2, 3, 4, 5, 6. So we've got 1, 2, 3, 4, 5 PEs. So okay, you only need it to the PE. You don't need it to the P as well. Otherwise, we would have a 6th connection. So yeah, let's take that out. I'm so confused. I'm sure I'm saying all kinds of things right now. I don't think it's, well, we've seen here that it's not true that the P routers have to, and I don't think there's a fundamental difference between the BGP configuration required for VPLS and for L3 VPNs. I think I'm wrong about that. Okay, but now we should have all the BGP neighborships coming up. They should come up really fast. Yes. Except for one of them looks, or a few of them look wrong, actually. Not sure what's going on with that. And also, why do I have 4 connections? I should only have... Oh, I see, because it deletes the most specific part of the exam, well, or sorry, of the command. Okay, so I think the problem with this is that the families don't match on these. I think the families have to match. Well, then why does this one come up? Which one is that even? It's R2. What's the difference between this one and the others? Oh, it just took a while. I thought it would go a little faster with it being passive on one side, but apparently not. Okay, I'll be back in a little bit. Well, actually, I'm gonna let's troubleshoot this. Okay, we've got no route to host. Oh, yeah, and we're missing a neighborship on G000. Which makes no sense at all. We're also missing family MPLS on the interfaces. I think we need that. I'm actually not sure. We might not need that on the PEs actually. Huh. Okay, well the problem must be on the other side. Oh, yeah, I completely don't have any configuration at all. Okay, so I think that's all I'm going to need. I won't need LDP because I'm not using pseudowire on here, although I might need it. I have no idea. I'm really confused. Yeah, I'm super confused. And then, do I need label switch paths? I'm so confused right now. I have no idea. Hopefully that BGP neighborship will come up now. Let's see if we've got an OSPF neighbor. We still don't have one. Oh, no, we do. Because this one has only 2. This one has 3. So hopefully this will... well, anyways, hopefully we'll roll for it now. Yeah, we do. So why don't we have a neighborship? okay. So it just took it a really, really long time. Okay, well that sucks. Okay, I'm gonna be back in a minute. Okay, so we're gonna keep going. We've got a half an hour before the cron job, so I want to make sure to use this time really efficiently. Aha! And the good news is I've completed all the configuration, so all that's left for this lab is the verification steps. So we'll start by verifying that the layer 2 circuit connection to Rudder 3 is up. The purpose, the purpose will be to verify that the layer 2 circuit connection from Rudder PE2, in our case Rudder 6, to Rudder PE3, in our case R4, is up. To also document the incoming and outgoing LDP labels and the circuit ID used by this layer 2 circuit connection. Alright, so let's verify this on Rudder 6. And it's down for OL, which really gets me. I don't know how to troubleshoot state OL. It's the worst state we could possibly be in. So I think, so it means there's no outgoing label. I think it might be because LDP is missing from the PE. Let's try that. Or sorry, from the PR9. Let's try that. And we also might need it on R8. Alright, let's try it on R8. Oops, for some reason. Okay, maybe that'll do it. I have no idea. Because L2 circuits require LDP. We are also having RSVP, but those are for our VPN. God damn it. Alright, let's do trace options on the L2 circuit. Alright, I want to just name these like L2 circuit. Yeah. Oh, okay, all my LSPs are down. That could be it. Because I noticed this transport LSP 0, so I was thinking they would have transport LSPs. Yeah, I think it requires family Mpls on these. Let's do some trace options under protocols Mpls because I think it spells it out pretty clear. Okay, let's try adding it. Yeah, that looks a lot better now. I think that was very much necessary. It's not a context ID. Yeah, now we can see these are, oh, we still have all zeros though. Okay, well, we haven't finished configuring family MPLS on this one yet. Okay, so let's set up the same. Okay, so I've got high hopes now. Let's go and check it again. Ah, I can already see state up. Oh, nope, but they're in state down. Maybe they're just transitioning. Lots going on right now. Okay, this is good news. Change to up right here. Change to up. So we've got a number of things changing to up. That's good news. Aha! So they're all up. So that was the problem. We needed family MPLS enabled on the P routers. Now I also enabled LDP, so I'm not sure if that is required as well. Let's try getting rid of LDP on Rudder 8 and see if it brings the Lsps down. Okay, and then we'll just roll that back. But I want to know if it's going to bring these Lsps down. We should see a bunch of messages pop up. Oh, we got messages popped up here. But we don't have anything popping up here yet. Let's try maybe clearing them out and seeing if they reform. Or maybe just give it some more time. Okay, yeah, I don't know. enough time to wait. Okay. Now let's see if they reform. Okay, they're transitioning to up, so that's a good sign. I'm pretty surprised. Yeah, so we don't need LDP. But it doesn't hurt to just enable it. Yep, they're all up. Okay. I mean, it doesn't hurt to have it though. But it's just nice to know what is needed and what isn't needed, so I'm not just shooting in the dark during the test. Like, to be honest, I don't even think I need LDP on. Oh no, I do need it on here. I do need it on the two endpoints with the L2 circuit, because otherwise that L2 circuit won't come up. Okay, so yep, now let's do the verification steps. So we're going to start with L2 circuit connections. Aha, so we've got one and the connection is up. Perfect. Oh, couldn't be any happier. I was actually not expecting this to work. So that leads me to wonder what was wrong with the other one where it wouldn't go up. I think the problem was I was missing that family Mpls from the P routers, just as it was here. Okay, so the output shows that the layer 2 circuit connection from router PE2 to router PE3 is up, and the connection is using the customer-facing interface. Note that the outgoing label, in my case, is going to be 16, and the incoming label, in my case, is going to also be 16. The virtual circuit VC identifier is 100, and the encapsulation in my case is Ethernet, same as theirs. Okay, so let's verify LDP neighbors and targeted LDP Lsps on router PE2, which is going to be the same router we were checking, router 6. Okay, so we've got 2 LDP neighbors. But I think the one on the bottom is the one we're interested in, because that's the LDP neighbor involving the loopback address. The output shows that router PE2 has an LDP neighbor with the IPv4 address of, in my case, 192.168.1.1, which is the IP address of the loopback 0 address on router 4. Notice that router 2 uses the local LO0.0 interface for the LSP. Verifying that the routers are LDP neighbors also verifies that the targeted LSP is established. Oh, okay. So this is the LSP that this L2 circuit is riding upon. If we do show LDP neighbor, so yeah, you can see. This is clear evidence that we only need LDP enabled on the endpoints of our L2 circuits. So yeah, let's go and disable that again here. Okay, so we'll disable LDP here, and now we should still have a neighbor. But as I disable these, we should see the second one drop out. It's not going to drop out when I disabled the R8 one, I believe, but after I disable the R9 LDP, we'll see it drop out. So let's do that right now. Okay, so we're going to see this first one drop out now that I've disabled it from R9. Perfect, dropped out. but we see this one stays. So for LDP, you only need it on the endpoints. And I think that's because it's going to travel over the LSP through RSVP. It's going to tunnel over RSVP. I guess I'm not sure. But yeah, everything looks great. I'm really pumped that this worked. I was not expecting it to work so seamlessly. The output shows that Rudder PE2 has an LDP neighbor with IPv4 address. In this case, the loopback address on PE4. So yeah, we got a targeted LDP neighbor, and it's a special LSP. It's an LSP based on LDP instead of RSVP, and it's required for our L2 circuit to come on. Okay, so let's verify the L2 circuit routes on Rudder PE2. To verify that Rudder PE2 has a route for the L2 circuit and that the route uses the LDP Mpls label to Rudder PE3. So that was the purpose. The action is going to be verifying that Rudder PE2 has a route for the L2 circuit and that the route uses the LDP Mpls label to Rudder PE3 using the show route table mpls.0 command. Oops, not 9. That's 0. Okay, so yep, we've got a L2 circuit route that pops. Yep, so we got it. We're using 16 instead. Oops, it looks like they've got another one here. Yeah, here's the second one we got. So let's take a closer look at that second one. Okay, so here's our core facing interface. So yeah, when it okay, interesting. But we can see, yep, it's using that RSVP static LSP that we made. So that's why you only need LDP end-to-end, because these routers basically have a wire hooked up between them that makes it so that they're hooked directly to each other. But it's a virtual wire. It's the RSVP label switch path. And that's why you only need LDP enabled on the endpoints, because they can communicate over that RSVP LSP and then build a LDP LSP. This one here. I'm kind of surprised that it's using .0 instead of 16 here. Don't really understand how that works, but because we saw the label was here is 16, but I guess it's like popping the label. Or like, oh, here the label is. I guess I'm not sure. Should say label 0 or something. Yeah. Or no. Okay. Yeah, I'm confused. I don't understand. Alright, well, let's just keep going. The output shows that Rudder PE2 pushes the outgoing label on the L2 circuit routes. So in my case, it pushes 2.7. Going out the customer-facing interface. The output also shows that Rudder PE2 pops the yep, so label operation pop is going to be popping label 16 because we're looking at labels right here. So we're looking at 16 and we see that 16 is being popped. Incoming label on the L2 circuit coming from interface GE 000. Okay. Yeah, I didn't understand that at all, but oh well. So let's move on to the next one, show L2 circuit connections. So it's up, I'm so happy that it's up. Okay, and that's for PE2. So let's move on to our equivalent of, I think, PE3 here, but this one belongs to the L3 VPN as well. So we'll look at this a little bit more carefully. Yeah, and we're gonna notice that here it's on the LT interface. Yeah. So I'm not sure which interface it was on the other one. Let's have them both up for side-by-side comparison. So yep, here now it's the customer facing interface. Here we have a special logical tunnel interface because it's going to be so here's our L2 VPN. So this is coming in, and then it's go in the L2 VPN. But on this side, it's going out to the customer. It's kind of like if you would think of like a glass of water. We've got a hole in the bottom that's spurting it out to like another jar that has like another hole in it. But like the glass is the L3 VPN, so like it's water doesn't actually work this way, so it might not be the best analogy, but it'd be like reverse flowing and then filling up the L2 VPN, but hopefully that's a good analogy, thinking of the L2 VPN like a glass of water or something like that, and then the L2 circuit is like a hole in the glass of water with like a stream shooting out, because that's basically, I think, a good way to think of it. So this LT interface is the hole in the glass of water. Yep, and we've got encapsulation Ethernet, everything looks good. Oh, I'm so happy this worked. Okay, so the next part is going to be verifying LDP neighbors and targeted LDP Lsps on Rudder PE3, which in my case is PE4. PE5 is going to be pretty much identical. Well, actually, no, it's not, because PE5 isn't going to have that L2 circuit connection. To verify that Rudder PE3 has a targeted LDP LSP to Rudder PE2 and that Rudder PE3 and PE2 are LDP neighbors, that's going to be the purpose. So the action for that is to verify that Rudder PE2 has a targeted LPD, LDP, label distribution protocol, okay, I read that wrong, LSP to Rudder PE3, and that Rudder PE2 and Rudder PE3 are LDP neighbors using the show LDP neighbor command. So it looks like they have two neighbors. I'm only expecting to have one. Yeah, I only have one, so I'm not sure what the extra neighbor is for. Yeah, I don't think they need the extra neighbor because it's part of the L3 VPN, so you don't need a targeted LDP neighborship because you're not going to have a L2 circuit. It's just going to be a part of the VPN. So if I do show what is it? If I just look at the actual table. Yeah, I should have a L3 VPN table. Yeah, I do. And then I should have another one. Oh, okay. So it looks like there might be something happening with my L3 VPN because I don't see. Yeah, I only see my local routes in here. I don't see the routes from PE5, although I don't have it hooked up to a customer there, so maybe that's what's going on. I mean, I can do that real quick. Oh, so I do have a, oh, okay, but that's, yeah, so I'm gonna configure this to the customer quick because I want to see a route to get exchanged. Oh, I got like 10 minutes. Okay, so let's see. Yeah. Oh, sorry, it's going to be that 2.1. There we go. Address. .0.2. Okay, so now, yeah, so this is AS6. Okay. Group. Oh, what the hell? Oh, okay, I used a different naming for some reason. That's pretty easy though. Could because of display set relatives. Look at how easy it is now that I know how to use the display set relative. First we gotta delete send. Yeah, see how easy this is with display set relative. Okay. Perfect. So now hopefully we'll see a new yeah, something in here. Hopefully we'll see. Perfect. Yeah, so we've got a BGP route now. Yeah, so now we've got things actually exchanging. Okay, so we should see a new routing table in here. It's going to be the BGP.L3 VPN.0 table. And the reason it wasn't showing up before is because there was nothing actually exchanging. Oh. Okay, well, never mind. Okay, I'm confused then. Yeah, I'm really confused. I don't understand why that table's not in there. So does this mean I can't ping the loopback on row 2 from here? No, I can't. Okay. What happened to... Oh, do I need a... Do I need a policy, like an import policy or an export policy? Let's do a show... Oh, it's still active. Why is it still active? Oh, you know what? I bet you I made it... I bet you I made it internal by accident instead of external. No, I made it external. Neighbor 10.0. Yeah. Yeah, I did it all right. Maybe it's just taking a long time? Secret ping it. Oh, no route to host. Okay. Well, it should be a directly connected route, right? Yeah, because it's right here. Why don't I have a route to host? That makes no sense. Why is there no route to host? There is a route. It's right there. Did I accidentally... Wait, I'm so confused. Why is it not able to connect? This makes no sense. Okay. Oh, no shit. Okay, I'm dumb. I'm dumb. So, yeah, there's no route to this in the inet.0 table. No route at all. But there is a route in the, oh, I forget what I called it. I think I called it like VPN-A. L3 VPN. Okay, so there is a route in the L3 VPN.inet.0 table. Yeah, right here. And there's in fact one here as well for that. Okay, so yeah, I keep getting that confused. Okay, so these are gonna reboot, unfortunately. I'm almost tempted to just say it's good. I guess I would like to come back and finish the rest of these verification steps. So let's keep going on this and try to finish the rest of these verification steps. But in 1 minute, it's gonna tank. I guess there might be a way to stop it, but it's not a big deal. I can probably use the break anyways. I'm going on 2 hours now. Alright, let's verify the BGP. Oops, so, okay, but this is to the customer, that's okay. Oops, it looks like we're missing, so we're missing a family. Okay, so I'm gonna need to come back though, because I've got my cron job reboot. Oops, yeah, and I reboot the entire GNS3 VM, so I lose access to the VM temporarily. Yep, so I'll be back in the, yeah, but the VM comes back really fast. It just quickly reboots the VM. So yeah, now everything's ready to go. But where I really have to wait is here when the devices boot up. So that'll be probably at least 5 minutes, more like 10, perhaps even 15. So I'm going to pause it, and I'll be back shortly. All right, and we're back. That's not even the worst thing. I needed a little bit of break anyway to gather my mind. Okay, so let's keep doing the verification steps. We're going to verify the router. If we think of, well, I put my glass in the kitchen, but if we think of the LVPN as a glass and then a hole in it for the L2 circuit, we're going to verify the router that has both the hole and the L2 the glass. So yeah. So basically we have, let me use Pete here. We have 3 different kinds of routers. So if this is our L3 VPN, we've got one router that's just a part of the L3 VPN, nothing else fancy or special. We've got another router that is going to be the most fancy and special router. And we've got another router that's outside of the LVPN. So the reason this is the most fancy and special router is because this is where the L2 circuit, this is the hole in the glass, if you will. All right, so let's move on. So we're checking the device that serves as the hole in the L3 VPN. Okay, and then that's, oops, so it looks like we've got oh, okay, maybe it's just taking a while after the reboot. It's the routing engines aren't all the way up. We can check that. Okay, it looks like it's online. Okay, so I'm not sure. Like, it was up before, so I don't know what's going on. It's to 92.168.2.1. Maybe I don't have a route to it. Yeah, I don't have a route to it. I don't have a route to it. Are all the other routers not out yet? Maybe the other routers aren't up yet. That could be it. Oh, okay, yeah. So it looks like some of them, the chassis is still coming out. Yeah, it's oftentimes difficult to tell when the forwarding plane is ready on these BMXs. Okay, but they're definitely not ready yet. So I think I'm going to put it on pause again and then come back to it in a few minutes. Alright, so I'm back. The cron job is completed. Yeah, it takes like about a half an hour. It takes a really long time, especially now that I ran out of my trial license on ESXi. But we've got all of the BGP neighborships up now, so let's keep verifying. Okay, so now here's something that's interesting. We're actually missing a table from here. Yeah, and we don't have the like if I do this next step, show route table L3 VPN. Okay, we're gonna have this table. Oh, okay, I'm on the route reflector right now. Okay, this is better. Okay, so yeah, but even here you can see we're not learning any BGP routes, and that's because we're missing a family from our BGP configuration. So we've got family L2 VPN signaling. Oops, so it looks like we do have family iNet VPN unicast as well. That's really surprising because I thought that was going to be the issue, that we didn't have that. I wonder if I need... Do I need iNet unicast as well? Let's try that. Yeah, I think I would need iNet. Oh. Okay, so this is interesting. So with iNet unicast enabled, we've got the iNet.0 table showing up here, but we want the custom table. So I would think that would be the iNet-VPN unicast would cause this to come up here. And then this L2 VPN signaling would cause these. So I wouldn't think that you would need that. Let's try getting this out of here because I don't think this is necessary. I'm not sure why that was included there. I'll do a rollback one on this. Okay, so now we're missing. Why are we missing the table? I'm so confused. I don't get why we're missing this table. So the output shows that Rudder P3 has a peer session. So we do have a peer session. I don't get why it's missing this one. Do I need a LDP neighbor? Is that why? Yeah, all my Lsps are up. What happens if I enable LDP on? Oh, but it's okay. No, it's just to the route reflector is where it's missing that. Okay, I need the route reflector back. I closed it too early. I'm so confused right now. Yeah, it's got family INET VPN unicast. I thought that's not what I would need. Yeah, this is what I thought I would need. Why isn't that working? Do I need to export? Is it because I don't have my C connection set up? I mean, I'll set that up. I'll set up my C connection. But the thing is, I have the C connection set up on this, and I still don't have it, so I wouldn't think that would be it. But I might as well just set it up anyways. Oh, here I've got it. I've got the. What do I have the? Oh, here I have it. What the hell? Yeah, you know what? I think it is because the CE connection is up. I don't have a export policy on this. Okay, but let's set up the CE connection, and I think that's going to be the answer to why this is not up. Oops, and I had to do a new one here, so let's Okay, everything's good to go. Let's go ahead and set up, configure this. Alright, so we're good to go. Okay, now things I hope will start to make more sense for me. Oops, or not. Why is it different on this one versus the other one? Why are they so different? Let's do a deep compare of the configs. I don't get why the just the same. Oh, this one's got to be PRS6, right? Yeah. Okay, this BGP neighbor should come up eventually. But this is interesting that this one looks good, but the other one does not. So let's do a deep comparison of the two configs after this is up, which is well on its way. There we go. Yeah, let's do a deep compare. Oh, you know what? It's probably because the interface is missing. Yeah. So, oh wait, no. From the L3 VPN instance. No, we've got the interface. We do have a lot of differences though. Oh, I see. On this side we don't have VRF table label. And this side we do. That's the only difference. Alright, let's see what happens if I remove that. I'm guessing it's going to explode or something. Okay, so now that I removed that, we do have this. So let's verify that when I add that back, that goes away. What the hell? Now it's here. What the hell? Okay. That's confusing. Alright, so let's try messing with the BGP configuration to the customer. Oh, before we do that though, let's do a rollback 0, and let's do a rollback 1. Yeah, we'll have that, oh wait, no, it's on there. Why? Okay, because it's part of the, yeah. Okay, so let's do a rollback 0. Yeah, well, that's good to have that on there. There we go. Okay, so let's see what happens without that on there. So right now, if I do a show BGP summary, we can see that table on there. So if I do a commit and then do another show BGP summary, it's still on there. What the hell? I'm so confused. I don't know why that wasn't there before. Makes no sense. Maybe it's gonna go away. Let's try to clear. Maybe it's just acting weird. Okay, so here we go. Now it's making more sense. Oh, nope, it popped up. So, I don't know if there's just some issue where it was late to pop up or whatever, but yeah, it's working now. So I don't know what was happening before. but let's add that CE configuration back. Okay. Oops, let's give it some time to come back up. Ah, perfect, it's done. Okay, we're good to go. Oh my god, something funny popped into my mind. Okay, so let's verify that Rudder CE2 has a targeted LDP LSP to Rudder PE3, and that Rudder PE2 and Rudder PE3 are LDP neighbors using the show LDP neighbor command. Okay, so we already did all that. Yeah, so the next step, yeah, and this is where I got confused at this step because this final routing table wasn't listed, but it's listed now. It just randomly popped in. I don't know why it wasn't listed. I don't know why it's listed now, but let's just keep going. Okay, so the next step is going to be to verify layer 3 VPN routes. So we're going to verify that Rudder P3 has layer 3 VPN routes to Rudder C2 and Rudder C3 and Rudder C5 as well. It won't have routes to C5 though. Yeah, so let's verify that. Yeah, looks good to me. Now they're going to be BGP routes, so we can narrow it down. Protocol BGP and see. Yeah, we've got the loopbacks. It looks like we've also got a. This is interesting. Yeah, we've got a. This is from the route reflector, of course. Let's see some more. Do we have any hidden routes? No. That's interesting. Is there like an originator? Oh, we originated from here. What route is this again? So this is 10.0. Okay, so it's just using my onion addressing. I know that it's 10.0.1, 2, and 3. So it looks like it's this link here. Okay, so there must be configuration on one of these routers where I include the physical link there. I thought I used a route filter, so I'm surprised to see that. I thought I used a route filter. Yeah, I did. So why is this network making it in there? Okay. Yeah, I have no idea. That makes no sense to me. I would think that only this network would make it in there, because do I need a then reject? I thought there was a default reject statement. That makes no sense to me. That That makes absolutely no sense to me. Okay, well, yeah, I'm not sure where this came from, but we've got the others that are more important. Yeah, we've got the two loopbacks. Okay, so the output shows that router, in our case R4, has a route to the IP subnetwork address. That is the interface address of the CE. Yep, so we've got that. Yeah, so we're good to go. Next step is verifying the layer 2 circuit routes on router PE3. Show route table L2Circuit.0. Perfect. Okay, the output shows that. Oh, did they have a detail? They forgot detail. The output they're showing here is from detail, but they didn't include it. Yeah, see how it matches now. This one looks like it's having a hard time here. It's not as big as this other one. Oh, okay, because this is a local route and then this is a remote. I don't know. Here they're looking at the local. Yeah, the local. Okay, let's verify the Mpls routes. Yep. So the output shows that router PE3 has a route for the layer 2 circuit, and that the route uses the LDP Mpls labeled to router PE2. Notice that the label is the same as the outgoing label displayed on router PE2 using the show L2Circuit connections command. Let's set up the CE to PE connection here, just because I want to see if I can ping from end to end on all routers, and if not, then T-shoot that. Okay, so we're going to use, oh, I see. Okay, so we gotta configure a connection here. Okay, and we can just put an address on here. Oh, you know what? I think this address is going to be yeah, because right now we've got a, well, let me use a filter. Yeah, we've got an address here. So I think this address is going to be in the same subnet as this. So let's do .254. Yeah. Yeah, that looks good. I don't see anything wrong with that. Looks good to me. Looks real good to me, actually. Okay, so let's see if we can ping .1. Assuming this will work, I'm not sure what's going on. Okay. Can't ping .1. Oh, Yeah, we can. Sweet. Okay, so let's see if we can ping the loopbacks. No, we can't. Huh. Yeah, so I think I've got to like export it. Like do a VRF export or something. I don't know what's going on. Yeah, so unfortunately, let's try opening all the CEs and seeing if we can ping all the CEs. If not, we're gonna need to. I'm gonna spend a little bit of time troubleshooting that. I'll spend until 6 o'clock if that's the case, and if I get there and I get stumped, then I get stumped. So ping to let's see what that looks like. Perfect. Okay, so the good news there, but the problem is we've got oh, right. Okay. Yeah. See, this is what's confusing me. Yeah. This I don't understand why this needs a IP address. Oh, okay, so I am learning that. That's interesting. But I'm only learning it on R2. I can ping it. Huh, but I can't ping the other side. Probably because I don't have a default route. Yeah, I don't have a default route. I need a route on this side. Yeah, for this one. Okay, I'll just add a default route. There we go. Okay. So what do I need on this? Why am I not getting it? Why don't I have it on this? So let's look at the difference in the PE Rudder configuration. Try to figure out why I don't have that. I don't have the table label command. Oh, sorry, I do have the table label command on the interface on the PE where the CE is not learning this interface. Oh, we should be advertising a route. Oh, I got it wrong. Yeah, we're advertising a route. I don't think we'll be receiving any. Oh, no, we are receiving. But we're just not receiving that 172 route. Yeah, we're not receiving this one. But here on R2, if I do these very same commands for the appropriate neighbor. Yeah, so here we're getting this extra route. But here we're not getting that for some reason. Yeah, and you can see we're only advertising it to one neighbor. So for some reason we're not advertising it to this neighbor. I mean, I can make a export policy. Oh, you know what? That's what the direct policy was for, and I removed that. So they actually had that. Yeah, they had this export direct policy. That was for this one with the label table. So yeah, I removed that. So that's exactly it. It's okay. Okay, this will do it. Oops. Oh, I already had the, if I go on show configuration, I already had the policy configured, it just wasn't applied. Yeah, see? Okay. Alright, so now I should be able to ping end to end to end without any issues. There we go. Oh, and it looks like I got an extra one too because, oh, right, because it's, oh, what can I think? Because it's, I'm having a lot of trouble thinking right now. Because it was a directly connected route, so it's the interface. Okay, so let's ping 192.168.0.1. Oh, that's myself, so of course it's going to ping. But we can also ping .2, and now we can ping 172.16.0.254. Boom, mic drop. So one thing I might want to do to make this more clear, so this link between R6 and R4 is basically like a link between it's basically like a link. So this connection here, ETH2 to ETH4, is basically like another P to C connection. So if I wanted to make it extra super clear, I could assign it a IP address that fits in with my onion addressing. So we've got 10.0.1, 10.0.2. So I could make that 10.0.3 because we're not having a IP address here anymore. It's a layer 2 connection, so I will prove that. So we do have an IP address on the configuration, but it's not an IP address connecting to the interface here. So if I want to make this extra super clear, this is going to be 10.0.3. So let's go and do that just so that's extra super clear. And then, yep, this was .1 on this side and .2 on the other. Okay, we'll need to fix the stack road as well. Okay, so hopefully this makes sense why this makes it more super extra clear, because this connection from here to here is basically the equivalent of one of these PECE connections. It's just we're tying it in. It's just, you know, from this circle here we can see that our L3 VPN is here. These are outside the L3 VPN, so we're gonna now technically it's inside the L3 VPN, but it's that way because we stitched it into the L3 VPN using that L2Circuit. So basically one of these links here is basically the same thing extended out to there. So using that onion scheme, that would make this link 10.0.3.1. So .2 would go on the logical tunnel interface on Rudder 4. Okay, and we're going to have actually two interfaces, we're going to have the CCC, and then we're going to have the encapsulation internet. I'm not sure if they're both necessary, because we don't have unit 0 assigned anywhere. I'm curious about that. Oh, we do have .0 assigned. We have .0 assigned there, and then we have .1 assigned to the routing instance. Okay, so .0 is used for the L2 circuit that stitches it, and then .1 is used for the routing instance. I doubt we need the peer, because we've got these weird like peer unit commands. I mean, I don't think we need these peer unit commands. Oh, you know what? No, we do, because this is how they're stitched together. So peer unit 1 and peer unit 0, these two units, unit 1 and unit 0 for the logical tunnel, are peers. So it can that's how it can communicate between the L3 VPN, the logical unit that's added to the routing instance, the L3 VPN routing instance, and the logical tunnel logical unit .0 that is a part of the L2 circuit, because they're connected peers like that. I am not going to remember that during exam day. Oh man, there's just so much going on. It's all over my head. But basically, I came here to change this. Okay, so hopefully that makes it extra super clear now that I'm using that onion addressing. So, and not only that, now that I'm using the onion addressing, one thing that can make it even extra super duper clear is adding a loopback on here. Oh, shoot. Okay, well, that was... Okay, so then I would need to add another statement like this. Yeah, so let's do that. Yeah, so we're gonna have to have a new group. Okay, so we've got the new group. Looking good. Okay, so now over here. Okay, now we can do this in a more technologically advanced manner than just that static route. We can go edit protocols, BGP, group, eBGP, set type, external, set neighbor, set 2, set peer AS10, and then set export loopback. Let's see options. Policies. Back. Set from Reflector. Dot actually do exact. Accept. Okay, so we're good to go. I think we might be missing one thing. I can't think of what it would be though. Oh, right. The local autonomous system. But that's gonna be it. Okay, so that should be it. Okay, now we'll show BGP neighborship. Might take a little bit of time for it to come up, as always. Okay, and now we've got the other loopbacks as BGP routes. So now I can ping all of the CEs. So hopefully this makes sense. You can see how this is basically like, you know, if this customers are a bank and they've got an L3 VPN for their locations in Wisconsin, but then oops, they need one for their location in Michigan, but it's not part of the L3 VPN. Well, you can stitch it into the L3 VPN through this through your network, and just stitch it right into the L3 VPN as if it were just a straight another CEP connection like this. You can set that up from a device that is not a part of the L3 VPN. Okay, so let's take one final look at R4, and then I think this is thoroughly complete. I'm really happy with this. I feel like I really accomplished a lot and really understand what I'm doing a lot better. Yeah, so here it is in all its glory. We've got the logical tunnel that we've got the encapsulation CCC for the pseudo wire. Then we've got the actual IP address on the pseudo wire, and they're tied together through these peer units. Family CCC is also required. Okay, and then it's added here, and then of course we need our export policies, and then we've got our CE connection here. So, yeah, it makes a lot of sense. I guess I'm going to do one final thing and just try to ping all the loopbacks from all the other routers, just because it makes me feel good. It's a waste of time, but it feels very ritualistic, and that's not always a bad thing to have rituals. Okay, so just ritualistically, we're going to ping all of the routers from all of the other routers, even including router 3. Take a look at the show route before doing that. Yep. Okay, so now 1 and 2 from router 3. Okay, so everything was a complete success. I really surprised. The last one did not end up this way. So I think it's because I'm getting a really good handle on L3 VPNs. I'm almost tempted to go back to the last one, but I don't think I have time to do that. So yep, that's the end of this video. I'm going to do one more video today for the last exercise where we do it for L2 VPN. And if I can, even another video, because my goal was to get 2 topics done today. Unfortunately, my final video will be on this very same topic, which is L2 circuits. All right, so thanks for watching and see you in the next one.